Today we're going to talk about titration curves. And first, just a reminder that a titration is a laboratory method of finding the concentration of something by using a neutralization reaction. So we're going to do an acid-base reaction, and in the process you can calculate the concentration of something that you don't know the concentration of. And these graphs are going to show how the pH changes throughout the titration. So first of all, you don't have to memorize any of these. If you understand how to sketch them out, you can just figure it out from the graphs. So I'm going to show you how to do that. The first graph is titrating a strong acid with a weak base. So first you have to understand the pHs of strong versus weak acids and bases. So remember, the pH goes from about 0 to 14. 7 is in the middle, neutral. Less than 7 is an acid. Greater than 7 is a base. And the farther you get from 7, the stronger it gets. So for the first one, we're going to start with a strong acid, which is going to give a very low pH. So we're going to start way down here at the bottom. We're going to end at a weak base. So a weak base is going to be just greater than 7. We'll say maybe 8 or 9. And what happens with the titration curve is that it stays about the same pH for a while, but then all of a sudden it will shoot up like this. And so a titration curve looks kind of like a stair step with kind of rounded edges. And the equivalence point is going to be about halfway between those at the vertical tangent. Not necessarily halfway, but more at the vertical tangent. And tangent means where the straight line would line up with your curve. So the vertical tangent here is going to be about right here. And notice that the pH is going to be less than 7. So the pH of the equivalence point, the red line is the pH of the equivalence point, that's going to actually happen at a pH less than 7. So equivalence point does not mean that it's neutral. It just means that that's when the moles of acid are equal to the moles of base. All right, let's do the next one. A weak acid and a strong base. This time we're going to start with a weak acid, which is closer to 7. It's still less than 7, but it's going to be a lot higher on the pH axis. And then we're going to end with a strong base, which is going to be a really high pH. So now notice that the pH of our equivalence point is going to be greater than 7. And the last one is if we have a strong acid and a strong base. So strong acid is going to be a really low pH, a strong base is going to be a high pH. And so notice that our titration curve is going to give us, I didn't draw it very well, but the strongs actually cancel each other out. And so the pH is going to be close to 7. And again, that's the pH of the equivalence point, which is the point when the moles of acid equal the moles of base. And then the last thing for this is how to draw a titration curve for a buffer. So first of all, a buffer is a solution where the pH remains about the same even when small amounts of acid or base are added. So for example, your blood has a buffer which keeps your blood from changing to be an acidic pH when you drink a whole lot of orange juice or something that's pretty acidic. So first of all, a normal titration curve is going to look like this. If you add a buffer, there are two things that change. One is the pH is going to stay the same for a long period of time. Eventually it's going to change, but it resists change. So it means it stays the same pH for a longer period of time. And then the other change is that the curves are a little bit more gradual. So instead of having sharp edges, they're going to have more gradual curves. And that is if you add a buffer. And that's all you need to know for titration curves.